All right, so before we jump into the new stuff in this lesson, let's do a quick review of what we talked about in our last lesson. So we're at lesson 5.3, and in our last lesson, we introduced this new form called point-slope form. Up until this point, we'd been doing everything in slope-intercept form, which we also call function form, which is y equals mx plus b, and the name helps us out there. We are looking at the slope and the y-intercept. And now we have a new form that's called point-slope form. So we're still going to have the slope be a part of it, but now we're using just any point. It doesn't have to be the y-intercept. And so if you remember, this form was y minus the y-coordinate equals m, the slope, times x minus the x-coordinate. And so when we were given the slope and a point, such as the point 3, 2 and a slope of 2, we did y minus the y-coordinate, which was 2, equals 2, which was the slope. So that went there. And then x minus the x-coordinate, which was 3. And then if you look at example 2, we talked about how when we have negatives in there, here when we do y minus the y-coordinate, that would be y minus negative 3. And so that would actually become y plus 3 because that's the simplest form there. And then since it's a positive 4, it's still x minus 4. So we talked about writing these equations. And then we talked about graphing them. And we talked about how we could look at this equation and pull out the point and the slope and plot that on a graph. So let's look at that real quick. So here, let's take example 2 for example. We see there that the slope is 2/3. Again, we're pulling that from there. And then it's y minus the y-coordinate. So this would be like, since it's y plus 2, y minus negative 2. And so the y-coordinate is negative 2. And then it's x minus the x-coordinate. So the x-coordinate would just be 3. And we talked about how we could plot that point, 3, negative 2, and from there count the slope up to over 3 or down to left 3 to have a slope of 2/3. So that's what we talked about in our last lesson. Now we're going to move on to a couple new things, still talking about point-slope form. All right, so before I gave you an equation and you graphed the line, and now all we're going to do is the opposite. I'm going to give you the graph of a line, and you need to write the equation in point-slope form. So here's the deal. What you need in order to write it in point-slope form is the slope and a point, any point. All right, so let's first find the slope. When we're given a graph, can either use it by counting the rise over the run. So here I go up 1, 2, 3, 4, 5. So the rise would be positive 5. And then I go over 1, 2, 3, 4, 5, 6. So the run is 6. And again, I know that this is a positive line because it's rising. And so I got a positive slope, which is good. The other thing I can do is use that y2 minus y1 over x2 minus x1 formula, which in this case, I'll call this x1, y1, and this x2, y2. So that would be negative 3 minus 2 over negative 2 minus 4, which is negative 5 over negative 6, which simplifies to 5, 6. So either way gives you the same slope. It doesn't matter which way you do it, whichever way you think is easier. All right, now I need a point. Well, as I look at the graph, I have 2 points. In fact, I have an infinite amount of points because remember, any point on that line is a solution. But I could even just focus on the points that they gave me. So here I have 4, 2 and negative 2, negative 3. It does not matter which point you use. In fact, the directions are going to ask you to write an equation with each point. So let's go ahead and use this one first, the 4, 2. So I have y minus the y-coordinate, which is 2. So y minus 2 equals the slope 5/6, and then x minus the x-coordinate. And that's your answer. And so in some ways, this form is really nice because before we had to do all this work to find the y-intercept, and now I don't need to do that because any point works in this form. I can also use the other point. Let's do that. If I use -2 comma -3, I have y, and this would be y minus -3, so that becomes y plus 3 equals 5/6. The slope is still the same, and then it's x minus -2, so that would be x plus 2. And both of those equations would give you the same line. And so that's what step 3 wants us to do, is to check that the equations are equivalent by writing them in slope-intercept form. So we're going to do that here. We are not going to do this for every problem, okay? I just want to prove to you that both of these equations graph the same line, okay, because they both came from that same line, and that they're equivalent. They're exactly the same, even though they don't look exactly the same. All right, so if I take the first one, y minus 2 equals 5/6, and then x minus 4, I'm going to start by distributing that 5/6. So I've got 5/6 x, and then it probably would be easiest to keep change and make that -4/1. So this would be plus -20/6, and then I'm going to add 2 to both sides. All right, I'm running out of room, so I'm going to come up here. So I've got y equals 5/6 x. All right, and now I got do a little fraction problem here. So I'm going to first write this as -10/3 because that's -26 simplified. And then I'm adding 2, and so I'm going to write that as 6/3, so they have a common denominator. So I get y equals 5/6 x plus -4/3, and that would be that equation in slope-intercept form, which you can see it's a little complicated. I'm glad that we have this other form so I didn't have to mess with that other than to check it. All right, now let's move to the next equation. Okay, so I'm going to take this second one here, which is y plus 3 equals 5/6 x, and then in parentheses x plus 2. So again, I'm going to start by distributing that 5/6 x, and again I'm going to write that as 2/1, so I end up with 10/6. Then I need to subtract 3 from each side, and so when I do that I end up with y equals 5/6 x, and then plus, I'm going to write this as 5/3, and then it's going to be minus, and instead of 3, I'm going to write it as 9/3, so I have a common denominator. I'm going to keep change, and I get y equals 5/6 x plus -4/3. And so hopefully what you notice is we actually have the exact same equations there. Okay, do you see that those are the same? And they should be the same because this is exactly the same line. So this step 3 that we did, we won't do every time, but what I want you to see is that even though we're writing 2 equations, they're 2 equations of still the same line. All right, so let's go ahead and move on to example 2. Now notice in this one, we don't have a graph. We're just given 2 points, and we're supposed to write an equation in point slope form of the line that passes through points 2, 3 and 4, 4. Now, we're going to write both equations, and the directions on your homework will say that. So we'll end up writing one equation with 2, 3 and one equation with 4, 4. But before we can write either of those equations, we need the slope. Now, when we had the graph, we could count the rise over the run. You could get out graph paper, draw your graph, plot these points, and then count rise over run. That seems like a lot of work to me. So when I don't have the graph and I just have points, I'm going to go to my equation. So y2 minus y1 over x2 minus x1. Remember, we're subtracting the y coordinates, subtracting the x coordinates. All right, so if you need to, go ahead and you can label this x1, y1. x2, y2. Remember, it does not matter which is the first point and which is the second point as long as you're consistent. So then I have 4 minus 3 when I subtract the y coordinates and 4 minus 2 when I subtract the x coordinates. That gives me 1/2. So that's my slope, is 1/2. Now that I have my slope, I can write each equation. So let's go ahead and start with using the 2, 3. So I've got y, and I subtract the y coordinate, which is 3, so y minus 3 equals my slope 1/2, and then x minus the x coordinate, which is 2. So x minus 2, that's the first equation. Or the second equation, I do y minus and subtract the y coordinate, equals still 1/2, the slope is still the same, and then x minus the x coordinate. And so again, you can see that once you have the slope, it's pretty easy to write both equations. And so again, in your answers, you will need to have two equations. And if we moved both of those into slope-intercept form, you would see that it is the exact same line that both of those equations represent, even though we're just using different points. If you were to plot each of these equations on a graph, you would get the exact same line. All right, so let's try it with number 3 now. All right, same thing. I need to start by finding the slope. So I'm going to use my equation y2 minus y1 over x2 minus x1. I'm going to go ahead and label my points x1, y1, x2, y2, just to make sure I don't lose track there. So I have 1 minus 3 over 1 minus negative 1. Be careful with those negative signs. Feel free to keep change if that helps you. So I end up with negative 2 over positive 2, so the slope is negative 1 or negative 1 over 1, whichever way you want to think about that. Now that I have the slope, I'm going to choose one point first, so I'll start with this one, this negative 1, 3. So I have y minus the y coordinate, which is 3, so y minus 3 equals negative 1, and then in parentheses, this would be x minus negative 1, and so remember that becomes x plus 1. So that's the first equation. The second equation would be y minus 1, because that's the y coordinate, equals negative 1. Again, the slope is still the same, and then x minus 1. All right, so we can write the equation in point slope form, whether we are given the graph or just 2 points. And again, you start by finding the slope, and then you plug in the slope and the points. And so if you're given 2 points, there's 2 equations that you can write. All right, that's where we're going to stop in this lesson today. Have a great day.